Unit circle is any circle with a radius equal to 1 unit. It is usually shown in 30°, 45°, and 60° increments as seen here. The unit circle can be used to quickly determine sines and cosines of 1 at various angles. If a right triangle is drawn based on an angle in the circle, the height of the triangle will be the sine of that angle, and the length of the triangle will be the cosine of that angle.
An ellipse is like an oval. It is a conic that cuts through a cone at an angle. The standard form is shown. A represents the length of half of the major axis and is always the square root of the bigger number. B represents the length of half of the minor axis and is the square root of the smaller number. C is found through a squared minus b squared equals c squared. It represents the distance from the center to the foci. Once all of the variables are found, it is a matter of plugging them in and graphing. As you can see in this problem, A equals 13, B equals 7, and C equals 2 root 30.
A Pythagorean identity is any trig identity that expresses the Pythagorean theorem in terms of trig functions. The three most common Pythagorean identities are cosine squared of x plus sine squared of x equals 1, tangent squared of x plus 1 equals secant squared of x, and cotangent squared of x plus 1 equals cosecant squared of x. Prove that tangent of x times sine of x plus cosine of x is equal to secant of x. So tangent x is equal to sine x over cosine of x, so we can substitute that into the equation to get us sine of x over cosine x times sine of x plus cosine x. And then that's equal to sine squared of x over cosine x plus cosine x over 1, which is equal to sine squared of x over cosine of x, and by multiplying cosine x over 1 by cosine over cosine x, we get cosine squared of x over cosine of x, and then that equation is equal to sine squared of x plus cosine squared of x over cosine of x, which is equal to 1 over cosine of x, which is equal to secant of x.
The sine function shows the rise and fall of the points on a circle starting from 0. So the standard form of a sine function is y equals a times sine of bx plus c, and then outside of the parentheses plus d. The a value is for the amplitude, the b value is for the period, like what the period represents, and then c value is the horizontal shift or the phase shift, and then the d value is the vertical shift.
So for this example, we know that the amplitude is 2 and the vertical shift is -5. So we start the graph at -5 on the y-axis and instead of 0, and we go up 2 and down 2 since that's our amplitude. So for this problem, we're doing sine of 4x equals square root of 2 over 2. And first we're going to say that sine of theta equals square root of 2 over 2. So that means that theta has to equal pi over 4 and 3 pi over 4. So now we're saying 4x equals pi over 4 plus 2 pi, and 3 pi over 4 plus 2 pi over 4, because it's 4x. So since this is divided by 4, this is going to have a lot of answers. So x can equal pi over 16 plus pi over 2, and 3 pi over 16 plus pi over 2. And plus pi over 2 is going to add another answer for every time it doesn't equal 2 pi. Once it equals 2 pi, we cannot make any more answers.
A rotation of axes is when a conic is graphed on an x and y axis that has been shifted a number of degrees. This results in an x prime and y prime axis. To find out whether the problem is an ellipse, a hyperbola, or a parabola, you would have to find out the standard form and then find the b term, the a term, and the c term, and use the equation b squared minus 4ac. If the result you get is negative, then it is an ellipse. If it's positive, it's a hyperbola, and if you get 0, it's a parabola. Then you have to find the degree of rotation, and to find that, the equation is cotangent of 2 theta equals a minus c all over b. To find the new x and y coordinates, you would use the equations x prime times cosine of theta minus y prime times sine of theta. That's what the x coordinate would be. And then for the y coordinate, you would have it be x prime times sine of theta plus y prime times cosine of theta. Then you would plug in your answers into the original standard form equation, and you'd get a new equation for the x prime and y prime axis. For the problem that has been playing out while the explanation has been going, after plugging all of the numbers in, the equation turns out to be 2.9839 x prime squared plus 0.0446 x prime y prime plus 4.7527 y prime squared equals 24.
A vector is any quantity that has both magnitude and direction. The magnitude of a vector is equal to the square root of the horizontal component of the vector squared plus the vertical component of the vector squared. The direction of a vector is equal to the inverse tangent of the vertical component of the vector divided by the horizontal component of the vector added to or subtracted from either 0 degrees, 180 degrees, or 270 degrees, depending on the quadrant that the vector lies in. Vectors can be multiplied by or added to other vectors and are generally written in one of these two forms. Okay, an example problem. If vector v equals 3, 5 and vector w equals -9, 2, what is the value of 3v minus 2w? First, you can convert the vector into variable form to make it easier to work with, since that way it just looks like a normal equation. Then you can write it out as an equation. Then you can just multiply and then add the equation together to find the answer 17, 11.